EmDrive enabling a better future. This is just the intro. EmDrive electromagnetic drive. What is it? Where did it come from? How does it work? What can it do? What happens next?
So, first of all, what is it? Well, essentially it is a propellantless thruster. Now, a conventional rocket achieves acceleration by expelling a mass in one direction, and the laws of momentum conservation means that the rocket will then accelerate in the other direction. What the EmDrive thruster does is to produce a force, which we call the thrust, in one direction. This is a force that you can measure. If you put your sort of hand against the end plate that's producing the thrust, you'll feel it pushing against you. And as with all machines that follow Newton's principles, it will therefore accelerate in the opposite direction. So this is not a reactionless thruster, because those things just don't exist outside of science fiction, but it is a propellantless thruster. In fact, it's the world's first propellant-free propulsion system. We originally developed it for spacecraft propulsion, and the public domain, if you like, now recognises that there are two major groups doing the development, one in the UK, which is ourselves, and one in China. Now, interestingly, these two groups have used different theoretical models. The UK group, my group, basically uses classic electromagnetic theory and physics. The Chinese group have tended to rely on modelling, three-dimensional digital modelling of the thrusters to derive the forces. But interestingly, the two theoretical approaches both give pretty well the same answer. So not only do the two different theories give the same answer, but two different sets of experiments also give the same answer. The UK group, ourselves, we've done we've built a number of thrusters, but the final flight thruster design gives pretty much the same specific thrust as the Chinese design. To most people, if you have two independent groups doing different work and coming up with the same answer, that is generally recognised as being a major step in the proof of any concept. Our work was originally funded in the UK by the government, and we then moved into a phase where we worked on private investment. And the end product of all this work was what we call a first-generation low-thrust technology designed specifically for in-orbit applications. Once the work has been pretty well agreed and established, we went through a process of transferring this work to the United States. This was done with UK government agreement. It was an export license approved by MOD. It was done under what's called a TAA, which is granted by the State Department, and in fact we actually transferred all our design and test data to Boeing. It's noticeable that any subsequent programs have not been acknowledged in the public domain. What we did in the UK was, having basically completed the research and development on the first generation, fairly simple low thrust technology, we moved into the really exciting area, which is what we call the second generation technology, where we're using superconducting cavities cooled by liquid gases. In fact, we built an experimental device cooled by liquid nitrogen, and showed that indeed this would give the theoretical levels that were necessary to give us the thrust levels that could be applied to launch vehicle and terrestrial applications. Okay, where does it come from? Well, in fact, the original concept goes back almost 40 years now to the depths of the Cold War, when we were trying to solve very difficult missile guidance problems, very important missile guidance problems for the strategic missiles, and we were actually encouraged to think the unthinkable. And it was during this sort of period, which is probably not encouraged too much these days, but we considered all sorts of approaches to the problem, and in doing so the concept of something like EmDrive came up. It was agreed that this had possibilities, but as always in these things, something else came along. It was actually satellite navigation which solved the problem without having to resort to these rather wilder ideas. So it all got put away, and in fact it didn't come up again until essentially probably about 9-10 years later, when I was working on a military satellite called Skynet 4, and during the early design phase of this satellite, it occurred to me that a military satellite could make great use of something like EmDrive. Essentially, it gives you continuous manoeuvring capability using a propulsion system with no signature. Okay, so this was rather an exciting thought, and when I moved into project managing of these satellites, it also became very clear to me that it would save an awful lot of money and would ideally be useful on commercial satellites as well. At this point, the commercial implications of this sort of technology were not too impressive to the people I was working with, so we agreed to part company, and I left to develop EmDrive in my own company. And SPR Limited has been up running now for about 12 years, and in that period we've gone through a number of iterations. The main things that, or the main milestones I suppose, have been an S-band demonstrator engine, a C-band flight thruster, and a second generation feasibility study. And if you're looking at the slides, you'll see what is the S-band demonstrator engine, the rather large looking device sitting on a turntable. It's one side is the thruster, the other side is an instrumentation platform, and the whole thing is sitting on a frictionless bearing and a very large air bearing. Now the total mass of that turntable is about 100 kilograms, and the objective of this was to demonstrate that we could indeed accelerate 100 kilogram mass in effectively weightless conditions using a reasonable input power. This is what we did, and the test video has been on the internet now for a number of years. The important thing is that this is a dynamic demonstration of EmDrive. It shows that indeed that it does obey Newton's laws, because it accelerates in the correct direction, and it also accelerates at a rate which is directly compatible with the static thrust that had been measured previously. So, so Newton can breathe again. Even we agree with him with our exotic EmDrive. How does it work? But essentially it is a resonant microwave cavity that has a truncated cone shape such that the guide velocity or group velocity, depending on how you wish to term it, is higher at one end than at the other end. This is all straightforward microwave physics, as indeed is the fact that because the group velocity is higher at one end than at the other end, means that you will get a higher force at one end than at the other end, which is all sort of, as I say, straight out of a physics or microwave engineering textbook. There are, however, complications. The relationship between the wavelength of the propagated wave and the diameter of the cavity is very non-linear, which means that any attempt to try and understand this with mechanical analogies like air pressure, it just fails. You do actually, unfortunately, have to understand the maths, and the maths is non-linear, and this does cause problems. But believe you me, if you go through the maths, it works out correctly. What it does show is that you can design these things carefully such that you get a negligible axial component on the tapered walls. And you can also show that the net force on that you get out of this cavity, which gives you the acceleration, is dependent on what's called the Q of the cavity. The Q of the cavity is a measure of the quality factor of the cavity. Every system has a quality factor. You hope that a mechanical structure like a bridge has one that's much lower than 1, otherwise it would tear itself apart in wind. However, something like a microwave cavity can have a Q value of 50,000, which means that the stored energy inside this cavity is very large, and that the forces that are produced due to the so-called radiation pressure are also significant. They're not large because radiation pressure generally only produces very tiny force, but when you multiply them by the Q factor, then they become useful. One of the other things that that has to be taken into account is that obviously to be a practical machine, the EmDrive has to obey the conservation of energy. Now it does this because the forces are produced, if you like, by the stored energy inside the cavity. As you start to use up some of that stored energy in accelerating the cavity and thus producing kinetic energy, that stored energy will naturally go down. The definition of Q is stored energy over energy lost per cycle. Therefore the Q starts to go down, and therefore the thrust goes down. So it's a completely sensible system that does indeed agree with the conservation of energy.